Okay, last in the series on a small power generation system using solar power, 12 volt power. Again, I'm using one of these Harbor Freight 5-in-1 boxes as a basis for the solar generator system because these things already have a lot built into it. They already have the inverter built in, the batteries built in, little cooling fan. So you got a little air compressor that's okay for, but really good for bicycles, decent for motorcycles, a little bit lacking for trucks, okay for cars. Got your 12 volt outlets here, battery gauge, all that kind of stuff, jumper cables so you can interface it with other equipment, little meter gauge. There's so much built into these that you might as well not even try to build it yourself if you're going to go with lighter capacity equipment. So that's pretty much it. Something else I'm going to show, and it's kind of hard because this camera doesn't zoom out very well, but in an earlier video I showed that I was using these the DeWalt and Ryobi tools with my solar generation system. This is one of the Solarland power charge controllers here that 10 amp, and so that's decent, but again, it's just got indicator lights. If I wanted to build a larger system or interface with a larger system, I would use one of these 30 amp charge controllers, but that's kind of where you're getting out of really micro systems and tiny systems. But I'm going to integrate this into a little bit bigger system. I'm going to show you, and as we get into the next small video series on this, I'm going to show you how we scale these things up, because a lot of this is scalable. Now, with converting things over to using AC plug, AC outlet type stuff, you tend to deal with 15 and 20 amp maximums on your power usage. With those 15 and 20 amp maximums, a lot of DC stuff requires thicker cable. So we're looking at using thin cable, smaller stuff. Standard power cord type stuff can still deal with anything that's going to be, especially 10 amps and under type stuff. So in this is a 12 volt charger from Ryobi, again, probably arguably the best of its kind in the business. If their tools were better, I would be happier, but their battery and their charger systems are really top notch. I don't know how much of this is going to come through in a video, but basically the inverter, this charger uses 6 amps in and then 3 amps out. So there's 3 amps gets used up in the conversion process to convert to voltage. It's actually increasing voltage, so it runs through some capacitors, increase the voltage to be able to charge batteries off of that. The DeWalt 12 volt stuff, again, a little problematic. This battery got roasted out on the last expedition. We haven't figured out why. And I had done the cord modification on the charger. One battery did fine. For some reason, this one didn't. I don't know what was going on. It was supposed to cut off when the battery's full. And whatever reason, that DeWalt one didn't do it, and it roasted a battery. The Ryobi stuff worked like a champ, and that particular the particular DeWalt charger that I was using has given me problems in the past. So that was why it was the one that I was happy to start cutting and slicing wires on it, because it was already a problem charger. So, if you're doing on-grid or you have AC plugs available, the DeWalts are superior tools. Just their battery charger system when you go off-grid is expect problems and have backups handy. It's just the only advice I can give you on that. The other thing I learned is that, again, I'm looking at maximum efficiency when I go off-grid construction. I ended up using this Pazload nailer quite a bit on a job. Now that I'm back, I'm cleaning it up. I learned that the charging system for this, now they come with kind of a cheese dick charger here, and it's a 6 volt battery. This is just a skinny wire, and for this to be real construction site stuff is You know, Pazload has good equipment, but this is bullshit. And so the way this thing is made is this AC adapter plugs into here, and then that's how you charge the batteries for this. Well, here's the thing I learned in reading this. It's a 12-volt adapter. So what this thing is made to get is just under 1 amp of 12-volt power, which means that when I start doing my power splicing and rebuilding cables and stuff, I'm going to take this skinny-ass wire, I'm going to be making it a hell of a lot shorter, and I'm going to do my cord adaptation system to get this thing to run on native 12 volt rather than convert things and go through this box and convert things to AC to charge this battery. I'm going to make it run native 12 volt. I'm going to cut out some of the extra crap I got to carry and cut out some of the power conversion that runs through things, again, because we have that poverty of a power situation happening whenever you're operating off grid with a portable power system. You know, you're just not going to be able to portably carry enough solar panel to be able to waste power. So again, shorter cables means less line loss. Now, something I figured out recently, and again, I've done a lot of stuff where we're converting 12 volt to work with conventional plugs. Again, these are polarized plugs. They're color coded on the insides when you cut them open, and they're polarized. The right side is your positive. The bottom side is just a safety ground, and when we're going DC with these, we just do nothing with it. We clip it off. We leave the prong on these plugs so that we don't accidentally flip them upside down and reverse polarity on stuff. Then the left side is negative. Another type of plug system that again uses 15 amp cords is very common in the computer industry, and because these are used with American and European style cords, they use a little different color coding. Now I got these that are transparent. It's a green, blue, brown arrangement, and if I remember correctly, I set this up so that brown is our positive on these things, and it's twisted, so you have to make sure you play with your, use your multimeter, make sure your polarities remain consistent, and you're splicing. Again, if you're splicing, you can create resistance in a line. There's line loss, so if I'm splicing and I make the cord shorter, that's kind of where I want to be when I'm doing off-grid stuff. We want these cords to be as short as they can be, but still get the job done, and leave you a little bit of room that if a critter chews on a cord and you have to splice it down a little more, you have some room to do that. I ran into that on the last off-grid expedition I did. At night, some critters chewed on some cords. No permanent damage, just a little bit of electrical tape kind of solved that problem. But it's something to be aware of. That you don't want to. You want to shorten cords if it makes sense to, but don't shorten them so far you can't splice them or repair them again. But what I did was I found it at a store called Free Geek. It's kind of a thrift store from computer stuff here in Portland, Oregon. A power cord extension for these types of computer cords. So what this cord had was it had one end like this, one end like that. I don't know how you argue which one's a male or female end on these things because they're both an inserted thing. But something I'd been discussing in some of the other videos is that when we convert a solar array system over to using regular AC style plugs, we have that issue where because you got batteries and you got panels, you got several items that are hot that we're putting together to build up our amperage. Every once in a while in the arrangement, you're going to end up with some of these prongs that are hot, and you get a little bit of a safety issue in handling. Now, I personally still think it's safer and better than doing stuff with this type of a plug connector, but there's so much made with these plug connectors, they end up being a fact of life. However, if you're going to go splicing wires and you don't want to mix up your AC and DC stuff and run into a potential problem of having a DC item that's been converted to using this type of plug, and then somebody plugs it into like a regular house outlet there and it starts burning your equipment up, or worse than that, you know, flipping circuit breakers or screwing up something in a house or apartment. One thing you can do is you can get these computer component extension cords that are computer industry relatively standard. I got a cord for $2, and so what I did was I spliced it into the middle basically and I'm using a new battery charger for this. I'm leaving the old one cigarette lighter plug only, because my camper trailer, the bug out camper trailer, has cigarette lighter style wall outlets. So this one's going to be set up to go both ways. But for that portable array, the carry-out array, that's been converted to AC style outlets. But another way you can do this is you can do your dogtail or your wishbone style connectors with these plugs, and then you're not going to have the same likelihood of mixing them up with your AC stuff. And again, what I had extra cordage on this, so I cut out the middle. That's not hard to do. The other thing, if you want to make a longer cord and you get these little fuse connectors, this is just the way they come from the factory. You would clip this and then put it in line on something so you can fuse your line with a relatively standard automotive type fuse. So in adapting stuff, you know, again, look at your devices, see which ones actually are a native 12-volt device with a connector end, and then again, take a bunch of this extra cordage out of the equation, shorten this stuff up, make adapters that go with these little connectors or even AC connectors, again with your polarity right, and your portable solar generator arrays are going to get really efficient and are going to get really useful when you do this, instead of having to run everything through, you know, AC adapters or cigarette lighter plugs. The other thing I found was that by splicing the computer cables into these AC cords and only using the thicker ones, I make some really nice heavy duty DC adapters here, and so by plugging these two in, these are basically both ends of another cord that got cut and spliced. You can't reverse that. That's got a shape which prevents you from reversing the polarity on a plug. And by plugging this in, I'm returning this whole battery charger to its original purpose, where, you know, it can plug into a car outlet or car cigarette lighter plug. Again, it's shorter. So if you got to reach from a dash under the seat or to the back seat, it might be a little bit of an issue. But the way they put power outlets in the backs of a lot of minivans and stuff now, this is going to be just fine. A lot of SUVs have that in the center console. You're going to be just fine with a shorter cord. You have less line loss. If I'm going to use a 12-volt system that's using regular house outlets, again, this is a computer power cord that's just been readapted with a double end here. And then again, I can't stress too much that you got to make sure your polarity remains consistent when you plug and unplug the stuff. Look at the color codes and the wires and make sure that goes straight. But by kind of adapting a little bit thicker wire into these things that have real tiny wires, again, if you read the little things here, you find out that it's a 12-volt item. This particular one is not a 12-volt item, so this wouldn't work with this system. This one is a 12-volt item, so you got to look at the stuff, make your adapters, make them short, make them with consistently slightly thicker wire. I think you're going to be well off for that. When I modify this, what I'm going to do is I want to leave this adapter alone. I'm going to find another thing with this tip and then probably adapt everything in to work with this type of a connector. I really like these because there's that less likelihood of having a hot lead that's bare metal hanging out. These things are kind of a double amorphous type of thing. And then what that does is that allows my the electrical component of my Pazloid nailer to be really off-grid capable. Whereas it was, you know, I had an inverter around so I could run an AC charger, but with adapting all that stuff, we get that. Now, here's the other thing to consider is that when you, of course that little light that I used, that one very similar to this at the camp. When you set your position up semi-permanent, all of this stuff can simply be integrated into a small building. I wish I could just do a Photoshop, a PowerPoint presentation for this, but my software isn't working too well with the movie editing. I can't narrate for some reason. This computer, the microphone thing wasn't working right. So, plan B. I have a dual screen system here, so I've gone over to Photo Bucket, and hopefully you can kind of see this in the video. But this is basically an outbuilding to a off-grid location lodge. I won't discuss the location. There's some people who probably would recognize this. But that's two 70-watt panels. A lot of scrap lumber was on site, so that's actually 2x lumber. It was heavily weathered. And what I did was I had more components left for making these portable systems. But we needed this to look like it's not particularly valuable from a distance, and the panels are over 20 years old, and they seem to be working fine. One of the people in the group I'm associated with who was able to, some people I'm working for, they bought these used, and it turned out we were able to use them. So as far as I could tell, this system was producing a good solid 10 amps, and which wasn't blowing out our charge controller. You know, pretty much a good match. And so in that system, we're going to change over. Okay, so that's our solar land charge controller there, and a 12-volt battery. The brick in there is kind of a placeholder for another battery, but it's also to add weight to the entire system so that we could not have it knocked over in the wind. Again, there's that DeWalt 12-volt charger. If you can see in the corner, it's difficult to tell on this picture. Let's see in the next picture. There it is. That's a standard house AC outlet running off the 12-volt. Again, I had to double and triple check my polarity, but what this does is this runs to another cable that actually runs to charge a couple other huge batteries that run a water pumping station for this location. Again, this was all built with scrap lumber, but it was 2x lumber. We get some splits in there because it's old lumber, but the price is right, meaning that it was free. The internals on this, the internal framework was all scrap pallet sticker lumber that I got for free. I did purchase some 2x3s because I needed some straight wood for the core of the frame of this system to hold the panels together. And so building this relatively quickly, I used a tape measure on some of it, but again, we were talking about an old warped lumber and not really a major need for precision as long as everything was fitted. So this whole thing was very low cost. Again, from a distance, it just looks like an old outhouse or something. There's a cord running out the bottom that runs to a water system, a water management system here. These are the big batteries. That cord terminates here at a tip. Again, all that does is it charges 10 amps, so there was no need to go with heavy wiring on that. But on the cross wiring for those two batteries, we got to use heavy cable. We ran that up to another AC style outlet, but that is not AC power. That is DC power, so it's going to run up to 15 amps worth of DC power. Until I was able to get the other system in there, I have the portable system charging that as a booster. And then off on the side, it runs a DC water pump for this storage tank, which, again, there's an adapter. I believe I was using 10 gauge cable for that. and we want to use the thickest cable that we can get away with that will fit into those things, and that works just fine. So you know, as a 10 amp battery charger, that's like your, you know, small to medium-ish plug-in-the-wall battery chargers. That's going to work fine to keep those batteries topped off. They're dirty, but they're actually not very old. And that's going to be my lead-in for the next video series here on how to take a small off-grid solar generator system. It's portable. You've seen the other videos. Here we're going to a non-portable application using the exact same equipment. This was that whole area is going to be enclosed as the people continue to work on it. And then what I had is exact same equipment, but here it's screwed and bolted into a small shed. It's a very small shed. Here you can see the scale of it. We just simply open up the back of it. All the wiring is easy to reach, although the connections have been very carefully put together so it's not loose, and it's weighted, and this is all 2x heavy-duty lumber with a brick in there to add a little bit of ballast so it doesn't blow away in the wind. The rocks down here are getting mortared so that doesn't move, and of course it's southern exposure. That's the angle for the latitude there, although I personally would have done a less steep angle. It seems to be working pretty well for that application. So that's a lesson that takes our portable array, and with just a little bit of upgrade, again, we're staying in that 10 amp limit because of the charge controller limit, but that's a respectable little power station for a off-grid location running 12 volt. That particular one is basically a very deluxe campsite where we can pull RVs up to and run that way. I know this is a long video, but I've hopefully explained a lot. We're wrapping up a lot with this on portable solar generator stuff. I know it might be a little bit boring for some people that I'm talking a lot about splicing wire, but it's important, because it's the type of thing that's going to get your stuff to work right and save you money and save you a lot of frustration when you're out in the field and you're wondering why your batteries aren't charging or why stuff isn't real happy with these types of plugs. And but when you can get a lot of modern equipment running in an off-grid construction location, and I ended up with this little shed built in about a day and a half with all the wiring done. This is a situation where there's a small lodge house at the location now that people can have, you know, regular showers and be clean and not be living in a filthy environment. Where, well, it is a filthy environment out there, but the people don't have to stay filthy. You can take decent showers in this water pumping system that I've helped out with. I handled the electrical component side. Some other people did the plumbing. And so it's a bug out retreat location for some people. It's going to be full-time residence for others, probably sooner than later. And that's how we can take our portable arrays. We can turn them into a semi-permanent application, because as things grow, it's the same technology, the same stuff. It's high school kid science fair level rocket science. Okay. It's not major rocket science. It's high school science fair kid stuff, and we can scale it up and then move up from there.